Hello, I'm Chris DiMartino, a Sales and Applications Engineer at Modelithics. In this shortwaves video, we'll talk about how Modelithics models can be used within Keysight Technologies' RFPro EM environment. This is the schematic in ADS of the filter design we're going to be looking at. For the inductors, we're using Modelithics microwave global models for the Coilcraft 0402 CS inductor series. For the capacitors, we're using microwave global models for the AVX UQCL series. Now let's view the filter in layout mode. In layout mode, we can go to Schematic in the toolbar and then select Design Differences. We'll click Update over here, and now we can place all the schematic elements in the layout, and then after we're done, we have the final layout of the filter. Remember, we'll also need to configure the substrate. We're now ready to launch RFPro. Let's go to Tools, RFPro, and then we'll select New. Now we need to drag the input and output pins from the project interface down to where it says Ports in the Setup interface. Now that we've set up our ports, we need to make sure that the component models are specified as circuit elements. To do that, we'll need to right-click the model up here and then select Change Component Role followed by To Circuit. Now notice that when we right-click a model, we see this option called Component Includes Area Pins in Net. Selecting this option enables the component solder pads to be included in the EM analysis. Since that's what we want to do here, we'll go ahead and select this option for both the AVX capacitor model and the Coilcraft inductor model. So now we need to select both models up here and drag them down here to where it says Component Models. Now for this example, we want to simulate from 50 MHz to 8 GHz. We'll select the simulator we want to use, which in this case is Momentum Microwave. After the simulation is complete, we can expand this results selection. And then we'll select Generate Subcircuit. We'll go ahead and choose Create View in Existing Cell. This will add a new schematic to our cell called Schematic Full EM Analysis. We'll also see an associated symbol called Symbol Full EM Analysis. Let's take a look at this new schematic. Here you'll notice we see each of the component models from the original filter schematic. Down here, we'll see this element that contains the EM analysis data from the simulation we just performed. So now we can go ahead and perform a final EM circuit co-simulation. Remember that we'll just need to add the proper substrate definition to this schematic. Now we need to create a new schematic, and then we'll just drag that symbol into this schematic. Let's add our port terminations, and then we'll configure the S parameter simulation. Again, we'll simulate from 50 MHz to 8 GHz. Now let's select our element, and then select Choose View for Simulation. Selecting Schematic Full EM Analysis lets us perform an EM circuit co-simulation of our design that incorporates the EM analysis data. Let's compare the EM circuit co-simulation results with the measured data. Shown here is one of the low-pass filters that was built and tested. The solid red traces represent the EM circuit co-simulation results, while the dashed traces represent measured data of 3 filters. We see good agreement between the EM circuit co-simulation results and the measured data, so we can safely say that we validated the overall EM circuit co-simulation model results. For a more in-depth look, check out the Deeper Dives video on this topic. To request a free trial, visit www.modelithics.com.